Good afternoon, everybody. My name is Ibrahim Oluwatosin Michael from North Carolina Central University, and I have my colleague here with me, Andy Egogo Stanley. We'll be having this presentation on mapping the racial disparities in prostate cancer mortality across North Carolina. Yeah, I'm originally from a background in geology, but this master's program in geospatial science at North Carolina Central has introduced me to the use of geographic information system and has made me get acquainted to some of the basic activities using geographic information system. So in the view of that, we'll be talking about mapping the racial disparities in prostate cancer across North Carolina counties between 2015 to 2020. Now, to start with, I would like to just describe prostate cancer a little bit because prostate cancer is a disease that basically affects men. So the women might not really bother much about this prostate cancer. It's a disease that affects the prostate gland in men. And the prostate gland is just a small walnut-sized gland below the bladder. The cancer cells that affect the prostate gland just usually start from small microgrowth of cancer cells, and over time will develop into bigger cells, and it affects the male reproductive system. And why have we decided to talk about prostate cancer? Prostate cancer is one of the leading cause of cancer deaths among men in North Carolina, and even globally, it ranks among the top 5 causes of cancer deaths among men. And why have we also decided to talk about North Carolina? North Carolina ranks among the top 5 states in the United States that has high occurrence of prostate cancer. So we have decided to use geographic information system to check the geospatial spread of prostate cancer across the counties in North Carolina. Our study area is North Carolina, like I said earlier, because that North Carolina ranks amongst the states in the United States that have high occurrence of prostate cancer occurrence and even prostate cancer related deaths. So we'll be assessing this across the 100 counties in North Carolina. And our particular focus will be checking the disparity between the occurrences in white and occurrences in African American cities, population of North Carolina. Now, to the objective of this study. The objective of this study include mapping prostate cancer mortality distribution rates across North Carolina. Also, we'll be examining the racial disparity in prostate cancer mortality. Then we will map North Carolina counties with the racial demographics with focus on African American and white male population. So where did we get our data for this study? The cancer death data was gotten from North Carolina Vital Statistics, which is a hub, like a repository that holds large data set of deaths in North Carolina. It doesn't just have cancer deaths, it has all records of all deaths between the time frame of 2015 and 2020. And we'll also be using the International Classification of Disease Codes to identify the specific deaths within the overall death that is specific to prostate cancer. And the ICD codes that will be mapping out for the prostate cancer death is the code 661. Other deaths, other forms of death, including different cancer deaths, have their own specific codes that we can use to map them out from the huge data set. For example, breast cancer has the ICD code of C50. So, but we are particular about this code C61 for the prostate cancer death. And we'd also be using socioeconomic indicators from the American Cancer Community Survey. And we got our shapefile, our North Carolina shapefile from NC1 map. And the shapefile also has several attributes like different ages of the people that died, from prostate cancer and other attributes that we'll be using for our mapping. And the software we used was ArcGIS Pro, the 3.3 version, and Microsoft Excel. Now, in terms of data preparation, after we downloaded the bulk death data from North Carolina Vital Statistics, it had some irregularities that we had to clean. Because without cleaning that data from NC Vital Statistics, our mapping would not really give the spatial disparity we are trying to map. So the first thing we did was to clean up the data and to identify specific prostate cancer deaths. And we also merge data from the North Carolina Vital Statistics with data sets from the socioeconomic database so that we can get a full spread of that integrates both the prostate cancer deaths and other socioeconomic factors that we mapped. Then, after merging these data sets using the merge tool in ArcGIS Pro, we did join process to merge to join prostate cancer deaths to the socioeconomic factors. Then we went ahead to calculate the mortality rate for each of the counties. Looking at this chart that we have here, it shows the total prostate cancer deaths in North Carolina between 2015 to 2020. And if we look at the trend, we can see that it's going on the rise from 2015. It's increasing all the way to 2020. And down here is showing the racial disparity. The orange line is showing that of the black prostate cancer death of black population in North Carolina. The blue one is showing that of the whites. The green is showing that of the American Indian or Alaska Native, and the light blue is showing other ethnic groups or other racial groups in North Carolina. And looking at this chart now, we can see that of the African American is the highest among all the 4 racial groups that we are looking at. And looking at this bar chart too, we can see that the bar chart representing that of the African American shows that the occurrence of prostate cancer deaths is higher in black race as compared to other racial groups in North Carolina. Now, here is a map showing the spatial distribution of cancer mortality in North Carolina between 2015 and 2020. And we normalized this map, the data for this map, using by 10,000 male population so that we can have a fair spread of the cancer death across all counties, irrespective of the population of the county or the size of the county. And if we look at this legend here, we can see that the light box here, the lighter shade box here, is showing lower cancer mortality rates, and the darker shades are showing higher concentration of cancer mortality rates. So looking at this map here, we can see that counties around Durham County and what's that? Okay, more counties like Durham County, Moore County, and what's this here? What do you call it? What? Edford, okay. Counties like Edford counties and other counties having this dark shade have high occurrence of prostate cancer mortality as compared to other counties that have the lighter shade here. So looking at this map that we have here, we have now, from here on, we decided to focus on the white race and the African American because the other racial groups are negligible. Because these two represent the bulk of the occurrence of prostate cancer across North Carolina between the time frame that we examined. And for example, looking at Moore County here, shows that about half of the occurrence of cancer, prostate cancer deaths, is more of the white population. Then places like Chatham County here is showing a larger concentration of African American occurrence of prostate cancer deaths. Places like Wake County also shows occurrence of more African American occurrence. And the places that have larger proportion of orange color shade are just indicating that in those counties is the African American population that have the higher occurrence of prostate cancer deaths. And looking at these edges here now, we can see that there is no record of African American prostate cancer deaths in all of these counties like Jackson County, Cherokee, Graham, and Swain County, all around you. This was just a record of occurrence of white population prostate cancer deaths that we have around there. Yeah. So I would let my colleague continue from here to talk about the other maps we have here. Thank you.
Okay. Yeah, so where before we showed the comparison between the white and the African American racial group using a pie chart, to better visualize the disparity, we overlaid the pie chart on a choropleth map showing the total prostate cancer mortality rates across North Carolina. And then you start to notice a trend. When you look at the eastern region, you see that the high areas with higher total prostate cancer mortality rates, you see that the black proportion, the African American proportion, contributes higher to said rates. So just doing some more visualization of the distribution, we have a couple more maps here that show the variation. Right at the top here, we have a map showing the percentage of the distribution of African American population across North Carolina. We see that the African American population is more to the eastern part of North Carolina than to the western part, as shown by the darker shades right here. And then, so looking at the map to the bottom left, we have a bivariate plot. What this does is it shows on the same map using color schemes the relationship between the prostate cancer mortality rate and the percentage of African American population. So areas where the dark purple represents area of high prostate cancer mortality rate, and then the light brown shows the areas of high African American population. So now the darker brown shows places where both the prostate cancer mortality rate is on the high and the percentage of African American population is on the high. And then you notice that just as we have the concentration of African American population here, we also have the area where they coincide to be around the eastern part of North Carolina. So this is something we explored further using geospatial statistical methods. We use the spatial autocorrelation analysis method. We use a method called the global Moran's eye. With this, we were able to run a spatial autocorrelation. We generated a report, and then this report showed us that at first glance, on a global level, when you look at it holistically, you see that it appears to be random. The variation or the clustering appears to be random. There's no clustering, there's no dispersion. The distribution appears to be random. So we decided to look further into the data and run a more local comparison using the local Moran's eye. And then it gave us this. So you see that the pink represents area of high high prostate mortality rate surrounded by high prostate contact. The pink represents areas of high value surrounded by areas of high value as well. But the light blue represents area of low prostate mortality rate surrounded by low values as well. And then we notice in this area, just as we saw in the spatial distribution, that there seems to be some kind of clustering here using the local Moran's eye. And just to do some kind of comparison to see if the urban areas, to see if this clustering happens more in the urban areas or in the rural areas, we did an overlay. And it seems to be that this concentration of high prostate mortality rate occurs in an area that seems to be more rural. And this could pose some more questions as to why that's the case. Exploring further, we did some more geospatial statistics. We ran a hotspot analysis using the Getty's odd method. And with this, we're able to tell, using more statistical methods, now we're able to explore the significance level. Where before we were just able to say, okay, high areas are surrounded by high areas as well. Now we are able to check the significance of this. And right around here, we see that the hotspot analysis shows that there is a high significance around here. So the clustering here appears to be significant. And then this appears to be a significant hotspot. This appears to be a significant cold spot. But then these other areas appear to have little to no significance. And you want to conclude?
So in conclusion now, we can tell that from our spatial analysis that looking at the distribution of prostate cancer deaths in North Carolina regionally, would want to think that the distribution is random. But when running looking at it closer, using the local Moran's eye, we can now detect that in the northeastern region of North Carolina, there seems to be some concentration of prostate cancer deaths around that region. And for further analysis, we would need to check the socioeconomic factors that really contribute to the seemingly high concentration of prostate cancer deaths in the northeastern region of North Carolina. Thank you.